YouTube, we're back. Okay, so hello YouTube. So if we shush in, okay, so shush. This is my name apparently.
You forgot the dash Y.
Dang it, I keep on doing that. Dash capital Y, by the way. Okay, because I don't have to do this when I'm here, but you know, so I don't usually do this. All right. Now, let's see. What do I do? All right. So if we gedit area, is that it? There it is. Yeah. Yes. Okay. All right. So who's got this working? Who's not got this working? How about that?
Who's not got this one?
Yeah. Who was stuck yesterday? Yeah, I know. It's off by one rectangle. I'm not going to fuss over that. The point of the graph is, look, let's run it. If you run area on, let's do something different. 2 to 5 in 8 on x of x. What's x of x? That's e to the x. All I care about this graph is that the curve is correct and that it shows it's an underestimate when it's an underestimate. That's all I care. Now, notice I did write n is 8, so I should see 8 rectangles, and do I? Well, actually I do in this one, don't I? Hey, that's weird. How come I didn't do it yesterday? Are you getting 8 rectangles? EXP is a Pythonic name of e to the x, the function e to the x. Did you now? Who didn't get 116? Really? Did anyone get 116? Okay. All right, let's see. It's 116, right? Let's go back to the code. Have this? What did you change?
I put 1 in for A, not 2.
Oh, no, different input. Okay. Everyone has to have the same input.
Yeah. That's fine.
I did that. All right, so here she goes. This is Smith. YouTube, we're stuck. Hang on. Anybody else stuck? We good? Can we good? Since you have this over here, I put in X. This was my input, right? 258 and X. X is e to the X. None for what? not? No. All right. Now, remember that we all figured out how to do right sum and mid sum. How do you do that? No, that's trap. We'll get to trap in a minute. Huh? You come from the other side, exactly. All right. So look, what if you change all the i's? Ready? See where the i's are? Remember what we did when we did +1, that gave you right? When we did +0.5, that gave you mid? Oh, well, we didn't do mid, did we? All right, look, I'm going to do this. Plus O, not 0, O for offset, right? Wherever you have I times H. Instead of I times H, make it parentheses, I plus O, close parentheses, all right? Here 2. Here 2. All right, hang on, I'm not done. No, not there. And then remember, not this one, because that's the bottom left-hand corner of the rectangle you're drawing. You still need that. But this one where you're taking the height. Okay? I put in I plus O in parentheses. 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 That's it. Those 4 changes. All right, now that means I need O. So let me put O here. This is the whole thing. All right, so put an O here. Put an O here. Okay, and put an O here. Oh, it's an O. Whoops. Okay. All right. So what do? I put an O here. I put an O here, and I input the O here. Okay. I put in. Where is it? I put in I plus O, I plus O, I plus O. Right. I got to do it here too. I plus O. I'm just shifting all the i's over a little bit. It's O, the letter O. Okay? All right, so we have I plus O here. We have I plus O here. We have I plus O here instead of I. We have I plus O here. And I plus O here instead of I. And we have I plus O here instead of I. Okay? I just changed all the offsets. We figured this out on Friday, didn't we? Okay. Are you ready? Now I got to put them here as input. All right, are you ready? Are you ready to test this? So what that does is it lets me do, if A is 0, it still does the left sum. If A is 1, it's going to do the right sum. If A is 0.5, we haven't done this yet, it's going to do a mid sum. And mid sum converges very fast to the answer. It's very good. Better than L sum and right sum. All right, so let's go from the top. Do you have find area? What did we do? We added this. We changed this. We changed this. We changed this, right? Do you have draw area? We added this. Well, actually with the comma, right? We changed this. We changed this. Do you have the rectangle correct? We changed nothing in here except for this. Right? Then we're going to ask the user for the offset. That's why I'm calling it an O, offset. And we're inputting it here and here. All right, let's see. Are you ready to try it? Are you ready to try it? All right, so I'm going to X out of here and try it again. All right, so let's run it. Now it starts with offset. If you put in 0, it's going to be the same graph, left sum. All right, 2, 5, x of x. This should be, well, all right, they're wrong. 258, sorry. Yeah, wait, hang on. If you do an offset of 0, that didn't change anything. That's going to be the same graph as before, the left sum, right? 258 exp of x, right? The same graph, right? But wait, look. What if you do it this way? 1, 258 exp of x. Now you have the right sum, which is an overestimate, isn't it? All right, who's stuck? Go back to the G-edit, okay. Yep, I'm coming. All right, what part? There or lower? Down here? All right, coming around, who's stuck? All the i's become I plus O except for this one. Who's still stuck? Stuck where? Me who? Here, Scott. I know. It's going to be somewhere between the left and right. All right, this is good. All right. So, now look, run it like this. If I run it for an offset of 0.5, and I do the same inputs, otherwise 2, 5, 8, exp. Now you're getting the midsums. But the midsum is closer to the answer. The right sum, I forget what it was. You remember what it was? 169, and the left sum was what? And this is in between. It's closer to the right answer. It's closer. All right. Look, try this. How about, what if we do an offset of 0, and you go from negative pi to pi in 10, and make it sine? What just happened? It's doing a left sum under the sine curve. See what it's doing? All right, so now that answer is negative. What is this answer? Negative 7. And what's this? Times 10 to the negative 17th. A scientific notated number is really, really small, right? So that's essentially 0. If you round off to like 3 places like we usually do. All right. Where did my graph go? All right, so my left sum is 0. Let's do the same thing. All right, now I'm going to go an offset of 1, make it a right sum, go from negative pi to pi in 10, and it's going to be sine of x again. Now this will be a right sum for the same function. Now it's a negative 7 times 10 to the negative 17th, and it's a positive 7 times 10 to the negative 17th. What do you think the answer is? It's somewhere in between. I think it's 0. All right, let's run it again. Let's do it for the midsum. Okay. Offset is 0.5. Start at negative pi, go to positive pi, go by as many as you want. I'm going to match it 10, make it sine again, and the answer is exactly 0. So midsum is the best of all three. Midsum gives you pretty close to exact results. Alrighty. Who's stuck? Yeah, just for fun, how about we do cosine? Let's make an offset of 0.5 and go from 0 to pi in one rectangle on cosine. Why did I get that? Because one rectangle, right? Okay. All right. So that estimate is again 0. Wait. Okay. Let me do something different. All right. Okay. I'm going to run this. Midsum is 0.5, right? Then I'm going to go from 0 to pi over 2. How about that? Pi divided by 2. Okay. With one rectangle under cosine. All right, so my estimate is about 1.1 something, right? Okay. Now, what would make... Yeah? You're stuck? You're not getting it? All right, hang on, I'm coming around. All right, now, listen. Shh. Remember, the midsum is the best, right? So how do I make it better? I'm going to stick with an offset of 0.5. That's the best. But I'm going to make more rectangles. Okay, so let's run that. So offset of 0.5 from 0 to pi over 2. And how about 10 rectangles under cosine? Now the answer is 1.00 something. Right? Now look, it's not easy to see if the midsum is overestimating or underestimating, but it was bigger, now it's smaller, so I guess it was overestimating. Okay? And it's getting closer and closer to 1, it looks like. Let's try it again. Overall, it's going to be an overestimate over the whole thing. All right, run it again. Offset of 0.5, start at 0, go to negative pi over 2. Yeah, I'm sorry. I didn't want that. Well, all right, leave it. Go for 100 rectangles under cosine. Now, why is it negative? Because I went to negative pi over 2 by accident, okay? All right. Run it again. 0.5. 0. Answer 2. Enter. Okay, how about 1,000 rectangles under cosine? Okay, there you go. Now, why is it black? What happened to the blue? Because, I don't know if you realized, all the rectangles have a black border. So since they're so skinny now, you don't see any blue. You just see the borders.
I just asked that question for enough rectangles with two black.
How many zeros? What do you mean? In your n value? Well, I'm not going to go beyond 1,000 because look at my answer. It's damn close to 1, right? That's your limit, basically. It's getting closer and closer to 1. Okay. So, let's do it different. Do it different. All right. Now, area is done. Oh, wait. Ding. I want to G-edit. G-edit. Okay. I need a printout from everybody. So go to the end of this first line, hit blank line, make another, pound? That's a comment. Put the name of the file, area.py, tab your name, don't write Mr. G, and tab today's date is fine. What's today? What the heck is today? 23rd? I just tabbed. There I'm tabbing. All right, save that and print that. Make sure your name's on it or you won't know whose is whose because we're all printing. Okay, so file, print, and go. And hand her in. Hand her in. That's a tab. Do spacing. Yeah. All right. This is classwork grade. Should be an easy 100. Just like your notebook check. Your Python files are your notebook pages. All right. So we've got Charles. We've got Kian. We've got Dallas. We got me. We got me. We got Dallas. We got Scott. We got Joe. Okay. I'll be on the bottom. Hello. I know what you did, but I couldn't fix it because somebody rebooted the server before I saved it. But it's an easy fix. Go ahead. And then we have Dylan, and we have Vinny, and Vikram. Okay. All right, we need a printout from everybody. Amazing. You're a computer scientist already. I'll make computer scientists out of you yet. Who's going to take computer science in college? Huh? Oh, with me? Hey. Yeah, but we don't do Python in there. We do Java. Yeah. You're going to major in computer science, really? So you're going to take AP computer science? All right, what do we got here? We've got Kelsey, we got Tim, we got Tyler, we got Avery, we got Deja, we got Dylan, we got Val, we've got Valtine and Peter. Okay, do we got everybody? See whose name? Your name? Oh, yes. Okay. All right, anyone still need to print out? Seat, here we go. Now that's a nice program for graphical output. But for numeric output, I want to see the convergence. I want to see the limits happen. Well, we can do it now. All right, so we're going to do it right now. You ready? Here we go. Yeah, we're going to need a new file. I'm going to call it, let's see. Let's call it, wait. Actually, yeah, part of this is going to be the same. You know what? Copy the whole dang thing. Control A, C. Control A for all, highlights all, C for copy. All right? Then make a new file. All right? G-edit. This file is going to be called LRMTE. It's going to print out left sums, right sums, mid sums, trap sums, and error estimates for trap sum. Just call this file LRMTE. It creates a file for you. Then right-click, paste, and you've got the old program, right? Or Control V, right? Okay. All right, now, I'm going to get rid of what I don't need. I don't need the drawing stuff. Get rid of this. and get rid of this. All right. So,
Wait, what'd you get rid of?
I got rid of anything that said draw. The last line was draw area, and the whole define draw area thing, get rid of the second define. Okay? All right, I'm getting rid of all the drawing stuff. Getting rid of all the drawing stuff. This is what it looks like so far, right? Okay, now this is LRMTE.py, save that much. All right, now I'm going to show you a new way of doing input, a different way of doing input, and a way of printing out a convergence table for left sum and right sum and trap sum and mid sum. And we haven't done trap sum yet, right? All right, so here you go. I'm not going to input like this. Get rid of this. Right? That's all you got. That's it. Now, we need all of this from the other program, but that's it. Now, this is what's different. Yeah, no, we're not doing graphing, so. All right, so this is what you're going to do. You're going to get A from, huh? Yeah, I'm doing input different. I'm going to do it a different way. Here's how I'm going to do input. Ready? A is the integer part of sys.argv sub 1. What does that mean? That means when you run the program, / well, the name is different now, right? LRMTE.py? Okay. When you run the program, / LRMTE.py, right? Don't hit enter. Hit a space and type your A. Hit a space and type your B. Hit a space and type your N, right on the command line. And hit a space and type your F. Okay, so that's what I'm going to do. I'm going to copy this 3 more times. This means take the first command line argument. Take the second command line argument. Take the third, take the fourth. This is going to be your B. This is going to be your N. Whoops. This is going to be your F. But this one, I don't need an integer. I need a string, so leave it. Remember, F is like, sign of X is a string. Okay? Now, let me show you how to print out left, right, mid, and trap. Okay? Does everyone have this? Yeah, this one doesn't have int because it's a string. This is going to be the actual function name. It's a string. So argv automatically gives you a string. You have to convert it to an int if you want a number, right? These are ints, like 258, right? Okay, now, what do I want to print out? This is what I want to print out. I want to print out if the offset is 0. Notice I'm not inputting the offset. I'm putting it right there. I'm inputting A, B, N, and F, right? But I'm not inputting the offset. I'm going to make it 0. Let's say, let me print quote L equals space quote comma. So that's the left sum. Okay. Well, what if I want right sum? What if I want right sum? What changes here? 1. Okay. What if I want mid sum? What changes here? 0.5. 0.5 or 0.5, same thing. All right. Okay. All right, let's test that much. So that's the whole program right now. That's the whole program right now. Well, I'm copying and pasting most of it. Okay. I just changed the input and the output. Really is all I did. And I got rid of all the graphic stuff. That's the end. That's the last line right there. All right. All right, so shall we test this much?
Yeah.
All right, save it. X out of it. Chmod it. Chmod 755 LRMTE.py. Because it's going to print out eventually left sum, right sum, mid sum, trap sum, and error estimate. All right, so let's run it. But it's LRMTE. LRMTE. Now remember what I said. The input's right here. Like, 2, 5, 8, x of x. Whoops. Oh, well, if it's, you have to put this in quotes, sorry. What happened? What'd I do? What'd I do? Wait, I did something. Get gedit. It's this. It should be ./LRMTE.py, and then the input goes here, like 2, 5, 8, quote, exp of x, quote. That should work. It doesn't like line 4. Hang on. This worked like last period, damn it. Yeah, it doesn't like sys. All right, hang on. This file works. I have in my hand. Works. It worked like 2 periods ago. The only thing that's different is that I got rid of the imports here, and I didn't get rid of the imports here. Do I need to import matplotlib for this? argv is the argument from the command line. Okay? In other words, it's argv sub 1 is this, argv sub 2 is this, argv sub 3 is this, argv sub 4 is this. Okay? Alright, I have a feeling that I need those imports. That's weird. I'm not graphing those. Alright, I'm going to bring those imports back. Ready? From matplotlib import everything. Alright, let's see if that's enough. Save it. From matplotlib import everything. Okay. It might be importing the sys class. That's the problem. Alright, there you go. Now it gave me something else. Alright, so I fixed the sys problem. Line 18. Doesn't like 18 or 13. 18. Doesn't like 18 or 13. Why?
I think we should just pick this up when we get along.
No, hang on. This should work. I just did this.
Wait, we need to. You put zeros for the.
Right, I want an offset of 0 for a left sum, an offset of 1 for a right sum, an offset of 0.5 for a mid sum.
Should you still have O's at the top?
Yeah, I'm plugging in 0 into this O. That's what that means. I'm plugging in 1 into this O. That's fine. That's good. This is a variable. This is what I'm plugging into it. All right, I'm missing something. Hang on. It doesn't like line 18, line 13. Why is it acting stupid?
What does callable mean?
Okay, hang on. I'm just going to put all the imports back. It worked just on here with all the imports. All right, from my PyLab. That's weird. I don't think I needed this import. Import everything. This is what we had before. I still had it in this version for some reason. Save it. Yeah, I guess you need PyLab. Oh well. All right, there you go. So there. Okay, this is what it looks like. I thought I only needed PyLab for the graphing. I guess it needs it for this. Okay. All right, so we need these 4 lines. We need these 4 lines. We need this function. And we need these 3 prints. Right? Okay, so look how nice this is. Look. You can run it now for, I don't know, 80. I don't know, 800. Do you see that the left sums are getting bigger and bigger and bigger? They're underestimating. The right sums are getting smaller and smaller and smaller. The mid sums are always stuck in between. And the answer is getting pretty close to 141.0. You're not getting that. All right, so, all right, let's see. You got it? Okay. Yeah, you need those imports. That's weird. I didn't think you need all of this imports. stuck still. Hello. All right, that's not a convergence table yet, but it's close. We'll finish this up tomorrow. You good? Okay. Who's stuck?
Enter.
It's a
From PyLab.
all right, what else is stuck?
Not me. I'm all bleach.
All right, we'll finish this up tomorrow. We're going to see how these values converge once it's done.
I know nothing. I know. That's this class.
All right, we're almost done. LRMTE is actually the more useful one. Area is nice because of the graphics. All right, so save it, X out of it, and X out of that. I know. And hello, YouTube. Goodbye, YouTube. Have a nice day.